This video is about Unit 1, Goal 5 and 6. So on the pretest, Goal 5 asks you to identify independent and dependent variables using the axes of a graph. So if we look at 17, if you wanted to determine the effect of changing the height of a ramp on the speed of a cart that rolls down the ramp, you would graph the height of the ramp on which letter. So to answer this section, you need to know that the independent variable is always written on the x-axis. You need to memorize that. The dependent variable is on the y-axis. So we have to identify for this scenario which is which. So if you're going to change the height of the ramp, that would be your independent variable, the thing the scientist is changing. He would measure then the speed of the cart. So that's going to be the dependent variable. So where would you graph the height of the ramp? That's my independent variable. So the height would go down here. So the height would be on B is the correct answer. So 18 and 19, just kind of recap what I said earlier. Where does the independent variable go? You just have to have this memorized. It's always on the x-axis, or in this case, it's labeled B. Dependent variable goes on the y-axis, which is A. One more scenario, number 20. If you compared the length of the string of a pendulum to how fast it moved, the speed of the pendulum would be graphed on which letter? So we have to identify independent and dependent variable. So if we compared the length of a string, we would measure how fast it moved. So this is your dependent variable. The independent variable would be how long the string would be. So we would change this. So the speed of the pendulum, which is how fast it moved, has to be on the dependent variable axis, which is the y-axis. So it would be on A. Take a minute now and turn to Goal 5 of the Your Turn practice, and let's try those. So for Goal 5, I can identify the independent and dependent variables using the axes of a simple graph. You just have to try these three problems. So 13, if you wanted to compare how changing the air pressure in car tires affects the gas mileage of the car, you would graph which variable where. Remember, independent variable here on the x-axis, dependent variable on the y-axis. So if you're going to change the air pressure, this is what you, the scientist, are going to change around, but you're going to wonder how is the gas mileage. You're going to measure how much gas mileage you get. So that's the dependent variable. So air pressure then has to be plotted on the x-axis because it's the independent variable. The gas mileage would get plotted on the y-axis because that's where your dependent variable goes. So 14, where does the independent variable go? It goes where B is. The dependent variable goes where A is. Goal 6, go back to your pretest and let's look at the scenarios here and see if we can figure out how to determine which hypothesis or conclusion is consistent with simple charts or graphs. So in this one, it's all about graph reading and understanding what's written in your chart or in the graph. So here you have to take a minute and look at the scenario. So a group of students were studying electromagnets, which is simply a battery connected to a wire wrapped around some piece of metal. This will become magnetic. So they took a nail, they wrapped it around 5 times, they connected both ends to the battery, they measured how many paper clips could be picked up. They repeated it 3 times. So trial 1, 2, and 3 were done with 5 loops of wire around the nail. Then they wrapped it around 10 times, and they took 3 trials. And then they wrapped the wire around 15 times, and they did 3 trials. The averages are listed here. So what would be a good conclusion for this experiment? So we are thinking that, well, if you look at the data, this is just a matter of looking at the data and thinking about what happened. So if I increase the number of loops, it seems like I'm picking up more 3, 4, and then 6. I'm picking up more paper clips. So I'm going to look for a conclusion that says that. The averages of the data showed no difference. I would say that's not true. The more loops of wire, the more paper clips lifted. That looks right. The more loops, the more lifting occurred. The more loops, the fewer paper. That would be wrong. And then there should have been more trials. That's always probably true, but this would be, there's enough for us to come up with a pattern, so this one would be right. All right, turn to the next chart. So this is for questions 22 and 23, this chart. So let's take a look at what happened here. So you've got a group of students tried this investigation. They took a 4-meter length of wire with a diameter of 0.5 millimeters. They attached the wire to a battery and measured the current. Knowing the voltage and current, they calculated the resistance. So this was just a calculation that occurred. They repeated the same steps with different increased diameter wires. So if we take a look here, they increased the diameter of the wire from 0.5 to 1 to 1.5 to 2 to 2.5. So that as you go down the chart, the diameter of the wire is increasing. So what happened with the current? They measured the current, and that also, as this increases, right, on the way down, this one also increased. Okay, but here, as you go down, the resistance, as you went down this way, the resistance actually decreased. So we've got two things that are going on here. Let's see if we can figure out by the choices which one's best. So for 22, what would be a good conclusion based on this data collected? So the larger the wire diameter, so that would mean as we increased our diameter, the greater the resistance. This would not be true because the resistance actually decreased. So that would not be right. If the current increases, so if I go down my list here, as the current increases, the resistance increases. This is also not true because the resistance goes down. If the diameter of the wire is lower, okay, what does that mean? The diameter of the wire is lower. That doesn't make a lot of sense to me. The diameter, so if the diameter is less, I guess, then the resistance will be lower, and that's opposite to what's going on here. So that's not right. But if the wire diameter is bigger, so as I go down here, there is more current measured. So you're getting a bigger value. So this has got to be right. Another possible conclusion would be, and let's take a look and see if any of these are written in a way that makes sense with the data table. The larger the wire diameter, so this would be, as we go bigger, as we go larger, the greater the resistance. This is wrong because it actually goes down. If the wire diameter is smaller, so that would be if I'm up here, there is more current measured. Nope, that's opposite. There's actually less current, so that's not right. All right, if the current increases, so as I go this way, the current increases, does the resistance decrease? This does seem to be true, because as I get bigger here, my values are getting smaller here. So this is going to be right. Just to check the last one, if the diameter of the wire is lower, the resistance will be lower. So the diameter is lower up here, but the resistance is actually higher, so that's wrong. All right, last one for this. What would be a good conclusion for the graph to the right? So here we have numbers sold of popcorn and the price. So we can see that as the price seems to increase, there's actually fewer numbers sold. So A, there is no relationship. I would say that's not true. There's definitely a pattern going on there. The more bags of popcorn sold, so the more sold, the higher the price. Nope, the more sold, it's over here on the lower end, so this is not right. The lower the price, so that's where we're over on the left side, right? This would be higher price, lower price, the more bags of popcorn sold. That would be right. The price per bag of popcorn goes up when more popcorn is sold. So more popcorn sold, nope, the price is going to be less, so that's wrong also. All right, go now to goal 6. on your turn and try these. All right, for goal 6, the first one, Maria's hypothesis was that water temperature would decrease if the water was deeper. Was her hypothesis correct according to the data? So we have to look at the table and try to figure this out. So does water temperature decrease if the water was deeper? So here's the water depth, and it's getting deeper and deeper, and the temperature is going down as you get deeper. So is it true that water temperature would decrease if the water was deeper? I would say yes, it's supported, right? The temperature went down as the water got deeper, so I would say yes. Next one, what would be a good conclusion from the graph to the right? Well, here we've got a student score graph, and we've got minutes studied. So as it seems like as they increase the number of minutes that they study, the point value does seem to be going up. So what would be a good conclusion? It would be something like as more minutes, as more studying occurs, right? As more minutes occur of studying, the points went up.